I want you to find the y values that correspond to these x's. Is that kind of making it sound so hard when it's really just plugging in every time? As far as organization, you guys could actually start on your paper figuring out all the y's. You could start saying, okay, we'll plug in -2 for x, what do I get? But for organizing your values, organizing your answers, a lot of times in math, we'll use a table because it just looks cleaner than having all these circled numbers everywhere, or cleaner than having all these ordered pairs everywhere. We can use something called a table that shows the data or shows the ordered pairs. So I'm going to use a table for organizing my answers. It's an option. I'm not going to require you guys to do it, but we are going to learn. We're going to use it more next time. So I recommend it. And generally when I have a table, I'll put the x on the left because it's kind of similar to an ordered pair, right, where x is on the left, y is on the right. I'm being consistent. I would say x, y, like that. So that then I can organize, when I put in this for x, what do I have to have for y for every single one. So the x's I'm going to use, I have -2, -1, 0, 1, and 2. These are the values that I'm going to talk about. So guys, when x is -2, how do I get y again? Oh, plug it in. Okay. Oh yeah, because y was equal to -2x plus 1. So I'm going to say -2 times -2 plus 1. What's that equal to? 5? Wait, yes, you're right. 5. Then I have -2 times -1 plus 1 equals what? -2 times 0 plus 1 equals what? 1. What's the next one? -2 times 1. Okay, -1. And the next one? Okay. In the table, you guys can put the equation if you want. If it makes you feel comfortable to show your work in the table, you can do that. Sometimes you'll just see the answers, though. That's kind of the neater way to write it, is to just put the numbers. But just make sure you know how they correspond, that one came from the other. I'll tell you more next class that a lot of times we use the x as what we're putting in and the y for what we're getting out. So even though we have this relationship, the way we usually as math people like to think about it is that x is the input and y is the output in the relationship. And that's why x is on the left. Usually you see it going in and giving us the y. Not required, not always, but that's just a general way we like to look at the two variables. I'll talk more about that later. But for right now, the objective that I'm hoping you guys are getting is what is the table and how does it organize the data. If I have x, I can get the y that goes with it. Another way for showing the same point. Let's see, what's the ordered pair? Ordered pairs that we just found. Just to make sure we're okay with our different ways of, that's not pair. Just to make sure we're okay with our different forms of notation, the table versus an ordered pair, what's that first one? -2 comma what? Then what? Oh, so it does read across, just like with the parentheses with the ordered pair, right? Okay. So what you're seeing in the table is the same thing that you would have been seeing if I had just listed out these points. So if I had, yeah, Kel. Basically what I was trying to show you here is I did not have to show you work. I did the work in my head. I said to get -1, when I plug in a 1, -2 times 1, that gives me -2, plus 1 gives me -1. Same thing for this one. I put in a 2 for the x. What do I get for the y? -3. When I substitute that in. And the idea, Cal, is a lot of times, like if you were looking in your calculator later in 080, when the calculator will actually do the table for you, it won't show you how the data is generated. It'll just give you those numbers. I wanted to write both in the table so you know that if I had only written that, it still means the same thing happened. It still means put in a -2, get out of 5. Put in a -1, get a 3. That's still the way you read it. We were just calculating by hand, so I was writing in the table.
Okay, so you're plugging in everything on the left for X.
And I could have switched it up. I could have given you a Y and had you go the other way. That's still fine too. But yeah, the idea is to get one of the letters, I have to plug the other one in. To get one of the letters that makes this statement a true one. And a table, when you have lots of numbers, is a neat way to store your data, to organize it. I could tell you to graph this. I bet you guys could. I'm going to say plot the points above. And I want you guys to get on that. I'll give you a second to plot them. Now, I don't have to tell you what to draw them on. You guys see an X and a Y here. You should be thinking the two-dimensional picture, right? The X and Y axis, I'll draw that. Just remind us. Always label your axes for me to remind me that you know where they are. That you know the Y is the up and down, the X is the side to side. It's funny that, like, people who don't do their homework, they'll get those mixed up. Even though it's such a basic thing, they will not remember X and Y. And I want to make sure I see you guys remembering it. Because it messes everything up if you don't. So let's see. First point we have -2, 5. Let's see. 1, 2, 1, 2, 3, 4, 5. Something like that. Is that what you guys got for this first one over here? -2, 5? Because remember, it's X, Y. So I went on the X in the negative direction 2 steps. In the Y positive direction from the origin, 5 steps up. That's the first point. What's the next point that also satisfies this situation? -1 what? 3. So -1, and then 1, 2, 3, I'm getting something like that. 0, 1. 1, -1, what's that? Describe it from the origin. How much do I go to the right? How much do I go down? What about 2, -3? You got it. Huh. If I connected those dots, what am I getting? Just out of curiosity. Getting a line. I bet we're going to learn about lines soon. That's a really cool relationship for X and Y to have, isn't it? Nice. So probably if I spent the rest of my life drawing dots, I would get a line. That's the pattern we're seeing so far. Good. The idea, of course, is that when you're doing this, if I had you just plot points, it might not always be a perfect straight line. This is a special situation for a special type of equation. I haven't taught you about it, so I'm not going to expect you to tell me if something's a line. Not yet. It's coming. But sometimes you might get pictures like, turn in your book to page 224. On 224, what you're looking at, see that the diagram there? It's called they're calling it a scatter diagram. You can also call it a scatter plot. By scatter, it just means, hey, I've got the dots. Maybe they're not making a perfect shape, but that's what you're seeing. Do you guys see the picture I'm talking about? Okay, so when you're doing your homework, you might get stuff where you don't see a pattern. where you don't see a pretty picture where you could connect the dots. That's okay. Sometimes in real life, the data is actually pretty random. Or in real life, maybe the data has a pattern, but there's a couple pieces that don't match the pattern perfectly. That's when statistics would come in the future, right? When you would start saying, well, how do I weed out the bad data and make predictions using what I've got? But for right now, I just want you guys to get comfortable with the basic graph, with organizing your stuff in a table, and with making those plots, with putting the points on the graph. Notice something for me, though. When you're looking at the scatter diagram, what's going on here? I mean, on the one we're looking at, they have age, and they have time in minutes. I'm assuming age is going to be in years, so I'll put that unit on there. When you're looking at any kind of applied problem, you do want to be careful about reading the margin, right? Read the labels on the axes. But how is it, I mean, didn't I just now teach you guys about a nice rectangular system where this is X and this is Y? So what's going on with this example? Why is it I only have this one chunk of data? What's going on? Why did it not give me the rest of the picture? Why didn't it give me this part here? Oh, you don't need it. Why? Very smart. We don't generally think about negative time, do we? We don't generally think about negative age. That's kind of weird. That's before you're born. What? No. So on the axis, it's possible to only look at the one quadrant, to only have this be the X, the horizontal, and this be the Y. And again, notice something. They are using age and time where age is the one that's kind of affecting the other. Because they're using the X one traditionally will be the input. It would generally be the independent one, the one that makes the other one change. That's just the traditional way to draw these things. And of course, I could put arrows. I think we have arrows on there, so you do that. This is the X, and this is the Y. And they tell you, when you do your homework, they will tell you which is X and Y. But notice the pattern is still there. The side-to-side stuff is X in those pictures. Even if I don't give you the whole plane, even if I just give you that one quadrant. How are you feeling? Merry Christmas. You guys just learned a section of material. Do you have questions or comments? I'm going to give you some lab time still because I want to make sure you get it. So we'll probably leave at 7 o'clock. Or we'll at least, take another break. So let's take a 5-minute break. I'm not giving you, well, you guys need a break. 5-minute break, since some people need it. And then we're going to work lab problems. But that's the lecture for tonight. For the rest of the time,